Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. We are still treating integration, and this time around we are going to consider boundary conditions. Boundary conditions. Okay, in our previous lecture videos, we used to solve so many questions under indefinite integrals, right? And we realized we normally add constant of integration, that's plus c, and we just leave it that way, right? So whenever we integrate, we add constant of integration, provided it is what? It is an indefinite integral. But in today's YouTube session, we are going to learn about boundary condition and what is the meaning of this boundary condition. This boundary conditions simply gives extra information in order to find or look forward for our c, which is the constant of integration. Do you get it that way? Alright, so let's visit the board. We learned that when you have dy over dx, which is equal to f prime of x, we know that dy is the same as what? F prime of x d what? dx. We've been doing this from the beginning. So if you are new here, kindly visit my previous lectures in order to appreciate this. So when you take integral of both sides, you have y is equal to integral of f prime of x, then d what? Then dx. So finally I can say y is equal to f of x plus c. This way. Now let's do it this way. Say let a be equal to, let's say, x, and let b be equal to y. What happens? Okay. Now wherever I see y, I'll put what? B over there. Wherever I see x, I put what? A there. As simple as that. So this becomes b is equal to, then f of what? F of a, then plus what? Plus c. We know this, we don't know c. So we make c the subject, that is the constant of integration, the subject. So c becomes b minus f of what? Of a. So having done this, we are now going to substitute this into what? Into this. So therefore, my y is equal to, what do we have here? We have f of x, right? So we have f of x, then plus c. What is our constant of integration? Our constant of integration is this, which is what? d minus f of a. As simple as that. Viewers, this is the concept behind what? Boundary conditions. So clearly, it throws more light on constant of integration. So let's the board in order to appreciate boundary conditions. Now the first person reads, a curve passes through the origin and its gradient function is this. So what is gradient? Gradient is the same as what? Dy over dx. That's gradient, which is equal to 2x minus s squared over 2. And this x is equal to 2x minus x squared over 2. Alright? So this is the same as, we have dy is equal to 2x minus x squared over 2 times what? Times dx. We take integral of both sides. I have y is equal to, now when you integrate 2x, you have what? You know that this is the same as 2x raised to the power what? 1 plus 1 over 1 plus 1. We know this already. Then minus, this is the same as x squared plus 1, then all over. I already have my 2 there on. You see, 2 is already there, I put it there. Then times, that's 2 plus 1. Then plus my constant of integration. So I have y is equal to 2x squared over 2 minus s cubed over 6, because 2 plus 1 is 3. 3 by 2 is 6. Then plus what? Plus c. So y is equal to x squared minus 1 on 6 x cubed, that's what? Plus c. 2 cancels 2, I have x squared. This is the same as 1 over 6 x cubed plus c, as simple as that. So we have a curve passes through the origin, okay? So let the origin be what? That's the origin. That's 0, 0, okay? Origin has the coordinates 0, 0. Is that also? What does it imply? It means my s is equal to 0 and what? And my y is also equal to what? Is equal to 0. So you put their respective values into what? Into the equation. For the question said what? Find the equation of the curve. So I have 0 is equal to x, but x is what? 0. So I have 0 squared minus 1 over 6 times x, but that's s cubed, but x here is what? 0. So 0 cubed plus what? Plus c. So straight away and clearly, c is equal to what? It's equal to 0. Okay, so you see the extra information we're giving in order to find for what? For the constant of integration. So this is what we mean by what? Boundary conditions. So to set up the equation, we are going to replace the value of c into this. And you get that in order to establish the equation. So I have y is equal to x squared minus 1 over 6 s cubed plus what? Plus c. What's the value of c? C happens to be 0. So therefore, our final equation becomes s squared minus 1 over 6 s cubed. Viewers, that is the answer to this question. We don't have anything like plus constant of integration anymore. Let's visit another question to throw more light on this. The question reads, the gradient of a curve at any point is equal to s squared plus 1 on x squared, and that y equals 3 when x equals 1. Find the equation of the curve. So in order to solve this puzzle, let's look at something. See the gradient. Gradient is given by dy over dx, which is equal to this. I have s squared plus 1 over x squared, and this is the same as dy over dx is equal to x squared then plus x to the power negative 2. Okay, so this is the same as dy is equal to s squared plus x to the power negative 2 times what? Times dx. Multiply here by dx, it cancels itself. Multiply here by dx. So you take integral of both sides. I have y is equal to, when you integrate x squared, we have what? That's x to the power 2 plus 1 over the new power 2 plus 1. Then plus, I have s to the power negative 2, add 1, then all over negative 2 plus 1, plus constant of integration. I have y is equal to s to the power 3 over 3, then plus x to the power negative 1 over negative 1 plus a constant of integration. So I have 1 over 3 times x cubed, then negative and positive, when they commit, so I have negative, then s to the power negative 1 plus my constant of integration. So finally, my y equals 1 over 3 s cubed minus 1 over x. This is the same as this. according to the law of indices, then plus my constant of integration. So find the equation of the curve. Is that also? So now we are saying that y is equal to 3, then x is equal to 1. Is that also? Because we don't know the value for the constant of integration. We know the value for y and we know the value for x. So let's do that, okay? In order to answer the question for in order to answer the first question, that is find the equation of the curve. This is not the final answer. Do you get that? Because we're giving extra information in order to find for what? For the constant of integration. So I have 3 is equal to 1 over 3, then x, that's x is 1, cubed minus 1 over x. X is what? Is 1. Then plus c. So I have this. So we have 3 is equal to 1 on 3 minus 1 plus my constant of integration. So c is equal to 3 minus 1 on 3, then plus 1. So c is equal to 4 minus 1 on 3. So therefore c is equal to, that's 11 on what? On 3. As simple as that. So therefore, let us establish the equation. So let's find the equation of the curve. So the equation of the curve is given by y is equal to, here, viewers. This is the equation, right? This is the equation we had. This is the equation. So I have 1 on 3 x to the power 3 minus 1 over x, then plus c, my constant of integration, which is what? 11 over 3. Now, you see how simple the boundary conditions are. So let's end the question now. Find the value of y when x is equal to 3. Okay, what is the original equation? The original equation was 1 on 3 x to the power 3 minus 1 on x plus c. Is that also? I said find the value of y given that x is equal to what? It's equal to 3. So how do you go about this? So we have y is equal to 1 over 3, then times x. X here is 3, right? So I have 3 cubed minus 1 over x plus my constant of integration, which is my c. I have it to be 11 on what? On 3. Why are we supposed to repeat the constant of integration? Constant means it doesn't change. Do you get that? Yes. So you still write down the constant of integration over here, its value. So this is equal to, okay, x here is 3. Alright. So therefore y is equal to, when we compute this, 37 on 3. Yeah. So therefore the value of y is equal to 37 on 3 when x is equal to 3. Viewers, this is the end of the lesson. I'll bring you another YouTube session to throw more light on boundary conditions. Those questions are going to be very, very technical. So follow me for more